Hi, it's Barb, Meeple PhD, with another Cosmic Game Connection. NASA recently announced that its NICER telescope on the International Space Station provided data to astronomers that allowed them to produce the first ever surface map of a pulsar. Now, pulsars are a type of neutron star, which are in turn the collapsed core of a star that died in a supernova explosion. Pulsars get their name because they have beams of light that sweep in and out of our view, causing them to appear to blink as the star rotates. NICER's ultimate goal is to help us understand what's inside a neutron star. These objects are so squished that they're a state of matter that we cannot replicate in labs on Earth. And in fact, they're the state of matter that happens just before a star turns into a black hole. By using NICER's exquisite X-ray timing abilities, it can provide data that leads to these surface maps. And these surface maps allow astronomers to determine both the mass and the radius of a neutron star. And that's exactly what this measurement was doing. But it came with a few surprises. For a long time, we've been drawing our models of pulsars with two beams of light coming from circular spots that arise from interactions between particles and the pulsar's magnetic field colliding with the pulsar's surface. And we've pictured that magnetic field to be much like Earth's, with poles on opposite sides of the pulsar. But two different teams, using two different analyses, found that this pulsar, called J0030, did indeed have two spots, but one was circular and one was elongated, and both of them were on the southern hemisphere of this star. And in fact, one of the teams found a third spot, also on the southern hemisphere. Now, both teams agreed that J0030 has a mass of about 1.4 times that of our Sun, and a radius of about 16 miles. Now, this single result isn't yet enough to tell us about the insides of neutron stars, but it is enough to tell us that these objects are a bit more complicated than our simple models would lead us to believe. So stay tuned to NASA's NICER to see what else we can learn about these wacky stellar corpses. When I heard about this bizarre pulsar, the game that came to mind was perhaps the obvious choice: Pulsar 2849. It's in the name! Pulsar 2849 is a dice drafting and action selection game where players imagine a future where we have harnessed the power of pulsars. Players must explore new star systems, patent new technologies, and distribute this pulsar-harnessed power throughout the galaxy. The game is set up with the exploration board in the center of the table, along with the technology board, the dice board, the die modifiers, and the gyrodyne board. 3 goal tiles are chosen at random and played face up. The transmitters are sorted and shuffled, and the first 3 of those are set up. And a number of silver dice, depending on the player count, are placed in the center of the board. Players take the rocket ships, player markers, and pulsar rings of their color, and also take one of the die modifiers. The game is played in 8 rounds, with each round having 3 phases. The first phase, the dice phase, the first player rolls all of the silver dice and places them in their appropriate places on the dice track. And then they determine the median position and mark that as well. And then players start drafting the dice, 2 per player in a snake-style draft, with the turn order determined by the initiative track. Players must also move one of their engineering or initiative markers up or down based on whether or not they draft a die that's above or below the median. In the second phase, players use their dice to select various actions. These actions include flying their rocket around and claiming planets or pulsars, patenting certain technologies, claiming or completing transmitters, completing projects on their headquarters, taking or spinning up gyrodynes, or simply taking a die modifier if they need it. In addition, it's possible for a player to get a bonus die, the red die, on their turn. They must spend it on their turn, and they have a max of 1 per round. And then there's the final phase, the production phase. The new turn order is determined based on the initiative track, and bonuses are handed out for the position on the engineering track, for certain technologies and transmitters, and for spinning gyrodynes. And then players prepare for the next round. After 8 rounds, players do a set of game end scoring. This includes scoring the game end goals, getting points for certain technologies, getting points for leftover engineering cubes or gyrodynes, points for their position on the initiative track, and a bunch of points maybe for how many star systems they've claimed. Player with the most points wins. Now, when I play Pulsar 2849, I think about the real pulsars that we've discovered. These amazingly bizarre objects don't quite get the respect they deserve. Think about this. They pack the mass of our sun into a region no bigger than the island of Manhattan. Some of them spin faster than blender blades, and they have amazingly strong magnetic fields. They're incredible. So the next time you pull out Pulsar 2849 and you find yourself spinning up a gyrodyne, take just 1 second and think about these amazing objects and the new unique picture that we're getting of them thanks to NASA's NICER telescope. Thanks for joining me. If you're enjoying these videos, please subscribe to my channel so they'll show up in your feed. I'll come to you again with another Cosmic Game Connection soon, but in the meantime you can follow me on Instagram and Twitter as @MeeplePhD, and you can follow my blog at meeplephd.com. And that's exactly what this instrument was doing, and that's exactly what this measurement was doing.